Well, good afternoon, everybody, and welcome to today's webinar, Algebra, a Balancing Act. Today's webinar is brought to you by COABE. Our presenters are Patricia Helmuth and Sherry Latimer. Patricia is an NYSED teacher, leader in mathematics, a staff developer for the Hudson Valley RAEN, a curriculum developer, and serves on the board of the Adult Numeracy Network, ANN, as the newsletter editor. She participated in both federal and state initiatives to create and curate high-quality math resources that are accessible and extendable for adult learners. She authored Push and Support Cards, a bridge to advanced mathematics for the multi-level adult education classroom, and Alleviate Math Fears with a Math Fair. As an ANN board member, Patricia has been actively involved in strategic planning and outreach for ANN and served on the ANN COABE Pre-Conference Planning Committee. Sherry Latimer is the director of the Hudson Valley Regional Adult Education Network in Newburgh, New York. Sherry has been involved in adult education for the past 11 years. She previously was an ABE instructor and technology integration specialist for Orange Ulster BOCES, where she discovered a love of teaching math and technology to adults preparing for the high school equivalency exam. Please say hello to Patricia and Sherry by saying hi in the chat box. Let us know where you're calling in from today. And you can submit your questions in the Q&A section of the webinar. And with that, I'll turn it over to Patricia and Sherry.
Hello, everyone. We are starting off today with an activity, and we're going to take you out of the Zoom a little bit. And on the screen, you're going to see two options to participate in our first activity. I'm also going to put this into the chat. Our chat is pretty full right now. We have 329 participants, so it may get a little lost. So I am going to post it now, and it is a Padlet. So if you go over to the Padlet, you're going to find a little activity that you can participate in as the presentation goes on. You can either go by the link or you can use the QR code on the screen. You've probably seen this type of code often lately, and there are some quick instructions on the screen. If you're using an iPhone, you're going to open your camera app. So just as though you're going to take a picture, but you don't actually have to take a picture. So you're just going to hover over the QR code and a link will appear that will take you into the activity. If you're on a Google device, you can go into your Google Chrome app, your Google Chrome browser app, and open the QR scanner. Again, you're going to hover over the QR code and let the app do the work for you. And you'll find a link that will take you into the activity. You're going to want to do this on a separate device than you're using right now, because you're going to, you'll see when you get into your activity what you can do with this. We're also going to use a QR code and Padlet for another activity later in the presentation. If you can't get this to work, no worries. You'll see all of the participation from others. And we do have quite a few today, so it's going to be filled up. There's plenty of room in there. You just have to scroll a little bit.
So hi, everyone. This is Patricia. Welcome to our webinar today. We're really excited to have everyone here. We're excited to have you participating in the number of the day. We're going to give you a few more minutes or maybe about a minute in order to be able to participate and think about that, and then we're going to move on.
At this point, I would go through the participants and say hello to anyone that maybe we happen to know, but we've got quite a few. I see 343 participants. I see Mary from Carthage, Missouri. Mary's using the Q&A, which is another option that you can use outside of the chat. If you, I would say that if you're not hearing sound, unfortunately there is sound, and you may have some issues with your speakers.
All right, so I think we're gonna move ahead now, but we do have that link in the chat area so that when we move to the next slides, if folks still want to participate in the number of the day, they can. So we already introduced ourselves. Well, actually, James did that for us. So what we're going to do is get right into our presentation. I'd just like to mention that one of the things that we're going to be doing today is to try to bring all our students together. Like they're all in the same classroom. They're all at these different levels. So how can we help all these students who are at different levels, different places in their math journey to come together, explore sense making, and all walk away with new understanding? So we're going to start by looking at a particular problem that researchers have used to try to get some insight into how students approach problem solving. So what do you think? What number goes in this box? And what might your students say? Now, you all may already have a number in your head, but what would your students say to this? Please go ahead and put a response in the chat box. And I'm also curious as to how you think your students, not only how they would answer, but what thinking may have led up to the number that students might put in that box.
I'm seeing lots of good answers. The first one that jumps out at me is, I don't know and I need help. Let's see. Eleanor, I saw that you said you couldn't get the code reader loaded in time. Don't worry about it. You can still keep working on it if you'd like. If there's a moment in the presentation, you can actually even work on the number of the day later on after the presentation has ended. And I think it's actually kind of fun to go back and see how many different possibilities everyone came up with on their first try. And that's very important, your first try with number of the day. Okay, Patricia, I'm seeing 7.
Mm-hmm.
Many are answering 12.
Mm-hmm.
I don't know what to do. I need help.
Mm-hmm. Yeah.
7, 9. Lots of 7s. How do you do it? I don't know. Our students would say 12. 12 because it's the first sum.
Right, right. It comes right after the equal sign.
Pam says they would think you should do 8 plus 4 to equal 12.
Mm-hmm. And just ignore the 5, right?
Yes.
Mm-hmm. Well, here's some background on this particular problem. It was the basis of research that was conducted not just with adult ed students, but it actually started with elementary students. And it was also conducted with middle school students. But let's see the results from a study that was done for adult ed students. So this was research was conducted by Pam Meter, who is a founder of the Adult Numeracy Network. She presented this problem to students who were sitting around waiting to be interviewed. They hadn't been tested yet. And she was curious as to how students' ability to answer this particular question would correlate with the level class that they were eventually placed into. Now, in her program, level A was the lowest math class. So what do you notice about her findings? So please tell us what you noticed by putting your response in the chat box. Now, I love some of these things that I'm seeing in the chat box because they're like exactly what our students would say. This is awesome.
Absolutely. 75% of them were wrong. 75%, 50% said that it's 12, 50% on level A.
Mm-hmm. So
50% know the concept.
Right, exactly. So the main takeaway that we get from these results is that our adult ed students very often don't have correct understanding of what the equal sign means. So what does the equal sign mean? You notice that researchers identified two different mindsets that students had in regards to this question. They discovered that students who had a relational thinking were able to answer more questions correctly. And that was true regardless of whether or not they had any formal algebra training. And these results really are interesting because developing understanding of the equal sign is something that basically, you know, we think that our students learn this in elementary school, but research is suggesting that often students at all levels are limited in their ability to solve math problems because they think of the equal sign as a signaling an operation, and the answer is, rather than as a signal to look for balance. Oops. Okay, so the goals for this webinar, knowing that we have little time with our students, what can we do to reinforce this relational understanding of the equal sign? And we're going to share some activities that support this relational understanding of equality and understanding that's based on balance, which is going to help our students to build towards higher level mathematics. Now, we asked you all to participate in the number of the day earlier in Padlet, and let's see what you folks came up with. Oh, wow, we have a lot of stuff here. Oh my.
It's fantastic.
Yeah.
I love that someone drew something.
So what do you notice about that? Please put your responses in the chat box. What are you seeing?
Visuals are very important. There are so many ways to see 12. It's kind of that old adage about math that it's not necessarily one answer. There's a million different ways to do math. There are a lot of contexts for the number 12.
Mm-hmm.
And this is day 1 for number of the day. On day 2, they challenge themselves even a little bit more. And on day 30, you can get pretty complex with your students.
Oh, wow. Here, look, let's go scroll down. Wow.
Lots of eggs and cupcakes. I like the social distancing. That's 6 feet plus 6 feet. That's 12. That's very apparent in our world right now. I love the exponent perspective, someone said.
And I like this comment, as in most math problems, there's more than one way to solve it, to come up with an answer.
Yes.
So look at what we did in just a few minutes. This is wonderful.
Oh, 10 and 2. Very nice. The driving. Doesn't
All right.
Yeah.
So we're going to move on and take a look at how students responded to number of the day. So what do you notice about this? Students were told that the number of the day was 9. What do you notice about their responses?
Oh, linear thinking, not very visual. Numerical math problems, all numbers, no connection to life. Interesting.
Mm-hmm.
Different levels of math experience.
Yes. Yeah, which is one thing I love about the number of the day is students at all levels can participate in this. You do not, everybody in the class, no matter what level they're at, can participate in this activity. But one thing I would like to just zero in on for a minute is this student who put this. And when she put that, I thought, oh, gee, this is great. She understands exponents. So I decided to challenge students and I asked them, let's try to do an equation that has 2 operations. And so she put this. And what do you notice about her second example? Sherry, is anybody? Because I can't see the chat.
There's an error in the thinking. It shows that there are different ways to express the number of the day. The right side is wrong. The second part is wrong. 6 minus 3 equals 9.
All right, so see, the second example shows she was really thinking deeply about that 9. She was thinking of how to decompose that 9, but she missed the meaning of what the equal sign means. So this really helped me to appreciate that just because our students are able to perform an operation doesn't necessarily mean they understand equivalency. Before we leave these student examples, I'd like to zero in on something you can do with these student-generated expressions because they made them, so they will like this. And that's to take one of the student expressions and put another student expression on the other side of an equal sign and ask students, is this true or false? This makes our students think in an entirely different way about equivalency. It tasks them to think about true and false. So we're going to move into more true and false statements right now because they're very valuable in uncovering student thinking because it requires more than just coming up with an answer. They have to evaluate both sides of the equal sign and decide whether or not the statement is true or false. Now, looking at these, you might think that they're simple, but what properties or laws of mathematics might come to your mind when you look at these statements? Now, go ahead and select one or more of the equations that you see listed. Say whether or not you think it's true or false, and explain why you think it's true or false. And please put your responses in the chat.
Ooh, we have quite a few not choosing number 6. Number 6 is usually the one that everyone seems to jump on. Okay, commutative property. 4 times 6 equals 6 times 4.
So they're learning algebraic properties.
Number 1, 7 does not equal 8.
Okay.
Number 6, 3 to the second power of 3 squared does not equal 3 times 2, which is 6. Six is false. Number 1 and number 6 are false. Number 6 is a typical mistake. I think that's very true.
Right. So when you start to solidify algebraic concepts using actual numbers, you can then start to phase in the use of letters in an unthreatening way. And once students see that these laws apply to all the numbers they use, they can recognize laws that are more formal. Although I really think it's important to say here that these laws of mathematics are true no matter what level of math your students are learning. They don't need to be named abstractly or formally like you see on the screen here. They're just things that are true about how math works, and they don't change. And students at all levels can benefit by articulating those laws in their own words. Now, to extend the idea of equality, you might ask your students, what could we do to make this first statement that we had looked at that we noticed was not true? What could we do to make it true? Well, there's a number of things. Of course, you could change the numbers on each side, add a negative number to one side or a positive number to one side to make it true. But another thing you could do is to bridge to inequalities, because just by putting that symbol in there, it does make this statement true. Now we're going to come back to true-false statements in just a bit, but we're going to look at another way to reinforce the idea of balance with our students. And that's by using visual models. This can help our students to gain a better understanding of equality in a way that's going to help them to actually see the rule. What you do on one side of the equation, you have to do to the other side. And I know that students don't really always understand what they're doing when they're following that rule. I had a student kind of sort of remembered that procedure, but when I presented her with that problem we looked at earlier, she did choose 12 for the answer. And I really wasn't surprised at this, because I saw her struggle to solve problems, because she was always looking for that algorithm. She was looking for a procedure. She was looking for a teacher to show her how to do it. And so using visual models is a way to help a struggling student to actually see the math, the numbers behind those rules. So we're going to look at a visual model now. And we're going to ask you to put in the chat, what do you notice or what do you wonder about what you're seeing on the screen here? And this is an activity that comes from the Desmos site, One-Step Equations Balancing the Hanger. I have used this in my class. Students really did well in getting a sense of balance with this activity. This is not the whole activity. This is just the first screen of this activity at Desmos. So, Sherry, what are people noticing about this?
I thought this was an interesting one. In language arts, we also teach parallelism with word forms, thinking, creating, and teaching. The words need to be equal weight. So this is kind of an interesting bridge from mathematics to language arts. Why would someone hang socks?
Good question.
The blue ones are the same color. They are not equal. Does one blue sock have a weight in it? What's in that blue sock? The second hanger is broken. Interesting. That's a different perspective I haven't thought about.
Yeah.
Why does the blue sock hang lower?
Mm-hmm.
The socks are unbalanced.
Mm-hmm. Okay. So we see these are real hangers with real objects, a concrete model that we're looking at. We can see there's something wrong with that one blue sock. Looks like down on the toe, somebody may have stuffed something. I don't know. When I first looked at it, I thought it was wet and that's why it was heavier. But we don't know. Desmos didn't tell us. So what we're going to do right now is move to a more abstract visual model of a hanger diagram. And we're going to ask you to put in the chat area what you notice about this hanger diagram.
A lot are saying it's balanced.
Mm-hmm.
They must be equal, but different weights. Teaching comparative form. 5W plus 2 must equal 3W plus 8.
Hmm.
So there's an equation right there
Mm-hmm.
in its simplest form. Need more ones to balance the right? Interesting.
Okay. I like this because there's different things that these
Yeah.
are the things we want our students to say. We don't want everybody to look at it in exactly the same way. Like what are you seeing? And just tell me what you're seeing and what you're thinking.
Each W equals 4 ones.
Hmm.
First one is wrong, it says. Left side is equal to the right side. That's interesting. Without even doing any counting or math work, can you tell if each side is equal or unequal?
Okay, so if we go back to the sock that we were looking at, we came to the conclusion that with the blue socks, that one sock must have been heavier for some reason, maybe weights in the toe. But the fact that this is, even though it's abstract, both sides are the same, I wonder what that means.
The hanger looks balanced, so the total weights on each side must be equal. W equals 2 circles, and then the next person says each W is equal to 3 ones. So it's interesting.
Well, let's take a look at this, thinking of that rule. What you do to one side of an equation, you have to do to the other side. So we see there's a bunch of W's on each side, some ones on each side. What if we take the exact amount of W's off of each side? And now what if we take the exact amount of ones off of each side? What are we left with? We're left with those 2 W's and 6 ones, which they must be equal since it's going to be balanced. Remember, if we take off those things that are in brown, and as someone already noted, that would mean that the W would equal 3. Now, this is a complicated model of a hanger diagram, and you might not want to start with that if you're going to use it with your students. So let's take a look at a progression that we could use to bridge to a hanger diagram like this with our students, and how using hanger diagrams can help our students to prepare for taking the high school equivalency exams. So these are 2 simple hanger diagrams. I sat in on Eric Appleton's Zoom class, and he had, what do you notice? He asked his students to comment, and these were some of their responses. They could tell that on the right, the diagram was not balanced, like the socks. They thought the circle was heavier than the square. On the left, the diagram is balanced. And they knew it was balanced, and I thought this was an interesting comment. Because the line on top was straight, they figured out the 2 squares are the same weight as 1 circle. So next, he asked his students, what do you wonder? And these are some of the questions that students came up with. So at this point, students are really understanding the idea of balance, that there is a relationship between the 2 sides of a hanger diagram. They understand that the hanger diagram on the left is not equal to the one on the right. And they're understanding that shapes are representing an unknown value, and they've developed some good questions to push the conversation forward. So at this point in Eric's class, he asked the students to imagine that the value of the square was 4. So in doing this, that helps students to figure out the value of the other shape. Students can create a math problem. They can see that 2 times 4 equals 8. They can see that 4 is not equal to 8 on the unbalanced hanger. And the hanger diagram, again, reinforces this relational view of equality. So I just want to spiral back for a minute to true-false statements as how they could be used with hanger diagrams. I'd like you to take a look at what you see on the screen here, taking the whole thing, the diagram. If a square is equal to 2 2/3, then the circle must be 4 4/6. Is that a true or a false statement? Please put your thoughts about this in the chat area. So Sherry, what are folks saying?
Okay, I see I see a lot of true, a lot of false. Someone said a typical mistake, that 2/3 doubled. I like the word doubled. 2/3 doubled is not 4/6. That's a common mistake with fractions.
Okay. So you could see that this was used not only to help students understand balance, it's used to help them understand fractions. It's used to help them to develop reasoning ability. So when they see those distractors on the high school equivalency exam, they will know right away, oh no, you can't double 2/3. It's not 4/6.
Yes, it does require fraction knowledge for sure.
Mm-hmm. Yep. So now once our students have had plenty of practice substituting numbers for the shapes, we can introduce a hanger diagram with variables. Now there's different ways that we can do this to draw out student understanding, and one way would be to ask them what value for W keeps the hanger balanced. Now, Eric showed this to his students, and then he annotated what they were telling him. And this is what he annotated in. And based on what you see here, what kind of sense making were his students articulating that they were seeing as they looked at this hanger diagram?
Great answers too. You can see some ahas happening in our own classrooms as we're using this very slide. The value of W is still the same as the last. Both sides are equal. They solved for W. That's really, sounds very, very complex, but it's presented here very simply.
Mm-hmm.
Now this makes sense. That's my favorite comment of the day. L. Alida Irvin. Now this makes sense. They understood the commutative law of addition.
Isn't that cool?
Yeah.
I mean, I sat there in that class and I was like, wow. And they didn't really know that rule, but they could see that was true. I thought, wow, that is so cool.
Bridget Barker says they set up an equation and they solved it.
Mm-hmm.
And it was so easy. It really was.
And now remember that the goal with using the hanger diagrams is for students to see visually and articulate what you do to one side of the equation, you do to the other. And so you can see with this simpler hanger diagram, if we subtract those ones on each side that were the same, it very clearly shows that the W would equal 3.
That's canceling. It's canceling for both sides. Mm-hmm.
But we could use this same hanger diagram Instead of asking students to solve for W, we could give students a multiple choice question where they have to choose which equation matches the hanger diagram and explain why they know that their choice is correct. And you notice that there's no W equals 3 in those choices. We're looking for an equation that matches the hanger diagram. This is a different way of thinking. This is set up like a test question that they might see in a high school equivalency exam. Again, there's distractors there, very similar to what you'd see on an exam. And when students do arrive at the correct conclusion that this is the one that matches the hanger diagram, then you could talk about why are the other ones false. So again, true, false questions. So let's go to a different way to use a different hanger diagram. There's so many different ways.
There's more.
So another way to approach it is to ask students to write an equation that matches the hanger diagram. And we're going to invite you to do that right now. So please look at the hanger diagram and write an equation that would represent what you see.
Wow, they're quick.
So Sherry, what are you seeing there?
I'm seeing 4x plus 8 equals 2x plus 26.
Okay.
4x plus 8 equals 2x plus 26. 4 times the quantity of x plus 8 equals 2 times the quantity of x plus 26.
Mm-hmm.
I
can't see the chat, so I'm not sure if is this what you're seeing?
It's fast. 2x plus 18. Let's see. A lot of participation. Fantastic. Thank you so much.
Mm-hmm.
This is very helpful. 4x plus 8 equals 2x plus 26. I do think, so interesting, x plus x plus x plus x plus 8 equals x plus 26.
Mm-hmm.
And that is absolutely a possible answer.
Right.
It can lead to understanding of combining like terms. The laws of math don't change.
Nice. Yeah. Okay, so we've looked at several different ways hanger diagrams can be used with students. If students, this is an interesting point too. If students understand how the hanger diagrams work, they can use them as a tool when they're tasked with solving for X, even if they don't know that rule. What you do to one side of the equation, you have to do to the other side, because they can draw a hanger diagram to help them to solve an equation. In fact, it's advisable to introduce students to visual models like hanger diagrams that represent the idea of balance before they're introduced to the formal rules, because then they will understand those formal rules when you do introduce them. And some of you probably already solved x equals 9, even though we did not ask you to solve for x, but your students will probably do that. We were just asking for an equation, but it's hard not to solve it, right? I would like to just briefly mention where these activities are coming from. So maybe Sherry, would you like to talk about this, the tools of algebra?
Actually, the tools of algebra comes from some, we like to call them packets that were developed by CUNY. This is the tools of algebra packets. It's one of 8 areas, or actually 16 packets that were developed in conjunction with NYSED and NYSED New York State Department of Ed, Adult Education Division, and CUNY, the City University of New York. They tried to determine what were the areas of math that were preventing their students from being successful on the TAS, which is New York State's version of the high school equivalency. And they determined that there were 8 areas where students are getting the answers wrong, but they are very easily remediated areas that can quickly get the student to the high school equivalency successfully. These are available I believe that Patricia's going to send out this link to where these packets are after the presentation, but they are a must-see. They certainly are.
Right, they're actually on the last slide, you will get access to a whole bunch of resources, all of the resources and more that we have available for you today.
That is my most asked question in the Q&A, Patricia.
What?
These resources will be available. The presentation will be available. The link to the packets, the link to the activities that we're going through today. You already have the link to the Padlet, and you can certainly add and look through what everyone else is posting. We'll keep it up for as long as we possibly can, but it's just one way that we originally were supposed to do this in person. And originally we would have used sticky notes and posters and tangible items that were held in our hand. And we decided that when we were presenting this virtually, that we had to adapt, much like a few of us are probably adapting our own classrooms across the country right now. Just a few technology little gimmies of different ways you can do things without being in the same room.
So we're going to practice using one of those technology pieces, which apparently nobody's going to have any problem with because it's the same one we used for number of the day. But here's the hanger diagram challenge, and this is our main activity. So the challenge is now to do the opposite. Instead of we're showing you a hanger diagram, we're giving you an equation, and we're asking you to draw a hanger diagram for the equation. So using a separate device, maybe Sherry
Yes,
would,
I certainly
yes.
could. So
explain how to do that.
same as before, using a separate device. This is more important to use your device other than what you're viewing the presentation, because this time you can take a picture of something in your world, or you can quickly post a picture of your work. So you can do it on paper actually, and then post the picture of what you did on your paper into the Padlet. So you're going to take a picture of your whatever you come up with for the equation, and you're going to choose the little camera, and that will post it in. I see that quite a few are getting the hang of it. I see a few being added already.
Cool.
Mm-hmm.
So while they're doing that, I just would like to talk about the Adult Numeracy Network for a minute. The Adult Numeracy Network, I just can't say enough about it. I have grown so much as a math instructor, and just the way that I look at mathematics after becoming part of this community. And I'm inviting you to become a member of our community too. It's a national community. The price of membership includes our newsletter that's published 3 times a year, and access to members only teaching resources and articles. There's actually an article I wrote in the last newsletter that's going to be available to you. It was based on this workshop. The article is called Algebra, a Balancing Act. It appeared in our last newsletter, so you'll get that. But if you join the Adult Numeracy Network, you will get all of our newsletters. So how is everyone doing with those hanger diagrams?
I'm getting mixed reviews about the hanger diagrams and the Padlet. Some just don't have the technology. Some are in a correction setting, and they're struggling with it. And in the correction setting, you can go back to the sticky notes and the wall. That might be just an easier way. This is just an option. You certainly wouldn't have to do this in your own classroom like this, and you can use good old-fashioned paper and pencil. But do you have Patricia, do you have access to that hanger diagram that they're posting?
Yes, and I also want to mention, if you do not have the ability to post to Padlet, but you would like to describe your diagram in the chat box,
Yes.
please feel free to do so. So let's see.
Yes, many are too.
Oh, wow.
Yeah.
Look at what we have here. Wow.
There's Eric Appleton now in the chat. He's inviting everyone to Adult Numeracy Network. They even have a newsletter that comes out. I'm sorry, Patricia, I missed if you said that or not. Correction settings, yeah. No separate device and corrections, for sure. So you can go over using the link if you have access to that, or you can probably give it a try later. What Patricia is displaying on her screen is how the Padlet looks. A Padlet is basically a wall of sticky notes. It truly is just the same.
This is so awesome. Look at all of this participation. So what are you noticing? Please put in the chat box what you're noticing about all of these different versions of this equation, all these different hanger diagrams. What do we notice?
On the left side, I would have 6's and the number 4, while on the right, I would have 3 X's and the number 10. Yep. Diagrams look similar, but not identical. So it's different interpretations of the same, different methods. It helps my brain to see this visually. Creative people thinking out of the box. I like the one that used a 6 and a six-sided shape and a 3-sided shape for 6x and 3x.
Let me scroll down the page a little bit.
Great way to teach factoring. Wendy Bopp says she remembers the math fair.
Hi, Wendy.
Love the different shapes. Good presentation. Yes, if you click on it, it will bring one to the forefront.
Yes.
Some of them are very, very simple. Some of them are very simple. Oh, what's the one with the X's over there?
Where?
The one with the lines right across.
I know. So this one right here.
Yeah.
So let's talk about that. What are we seeing?
Ooh. What are we seeing there? Reinforces that there's more way. Okay. What do you think about the one that Patricia's displaying? What if that was your student? What would that tell you about your student? Canceling. Oh, someone uses color rather than shapes. Okay, critical thinker. Matching and elimination. Canceling out. Yep. Across the equal sign. I like that. I'm sorry, Patricia, you were going to say it.
No, I was thinking that was really an example of what you do to one side of the equation, you have to do to the other side. That was a visual model.
Yeah. Without teaching it in a procedural way. It's a very visual way. I remember learning it very procedurally, and I didn't quite connect.
So I thank you so much for all of these wonderful examples that you shared with us. But we are going to have to move on. And to the part that some of you asked about, which is the resources. So in the resources, you're going to find research articles from elementary school and middle school. That problem that we looked at in the very beginning, what that research was really so extremely interesting. And there's ready to use classroom materials in the workshop resources. If you either use that QR code or that the URL there at the bottom of the page, it will bring you to a folder that has all of that stuff in it. Now I have a student work release form in there, and that's because I am asking you if you do any of this stuff with your students, I am the newsletter of the Math Practitioner for the Adult Numeracy Network, and I would love to share how that went in your classroom. So there's a student work release form. If you want to share student work in our newsletter, let everybody else see it. Just make sure your students sign that form before you send on any samples of student work. So that's our contact information. And my call to action for you is to find out what your students think the equal sign means, and then help them to develop a relational view of the equal sign. And as I said, if you use either just even that specific equation with your students, or anything else in this webinar today, or the resources that we're providing, please reach out to me. I'd love to hear how it went. And I think James may have a poll for you, or do we have time for a Q&A? Were there any? Is there any Q&A we need to get to?
Where do we obtain access to the number of the day? I can put that Padlet link also to the number of the day. I'm going to put that in the chat now. I did just put the link to the resources that Patricia just had up on the slide. Some are saying that they cannot get the link directly from the slide. So I did just post that in the chat, and I'm posting the Padlet to the number of the day right now. I just posted it. And I'm also going to post the hanger diagram, which if you are not able to access it during the presentation, please feel free to add to it to go in, and you could probably ask questions on each other. Someone just used apples and cherries, and these examples are fantastic. And once you get so many examples of something, you will see the creativity start to flow. On day 1, you're going to get great things. On day 10, you're going to get even better. So keep it up and don't give up on day 1.
And there's also a number of the day resource in the resource packet that we're making available to you. And Sherry, you said you did put that link in the chat. Because sometimes I can see the chat and sometimes I can't.
Okay. Okay, there's a webinar poll that just popped up in my screen. So if you would be so kind as to take that webinar poll so that COABE can decide whether they may have us back someday. Okay. Thank you so much. And I think I posted all of the Padlets. I'm going to post them just once more because we really do have a lot of attendees, which is really fantastic on a cold day. Well, we're in New York and it is a cold day in December, and it is really nice. I guess it says a lot about us that we like to sit around and do math on a cold day in December. And I'm going to repost all of those in the chat.
Yes, and thank you everybody for coming today. This was really a great experience, but we still do have a few minutes. If you've already filled out your poll, if you have any questions, please, we'll hang around for a couple more minutes.
Wow, intense. Okay, I'm going to just double check the Q&A. An email with the resources would be appreciated. And the other question, I think that's on where did you get the hanger visual activities? So that will be in the that will be in what Patricia has put out as the resource, and I'm going to put that link in the chat right now. Once again, it just said that it can't be loaded. I think we have broken the internet, Patricia.
Can everyone see my screen right now?
Oh, good call. Yeah.
So Collect Ed New York has those packets, the ones that Sherry talked about. If you go to the home page and then click on the Fast Track Grasp Math packets on the first page, it will bring up all the packets that are available. The one that we were looking at today was this one here, Tools of Algebra, Expressions, Equations, and Inequalities. So that's where you can get the specific hanger diagram models. The one model was the Desmos activity, so you would have to go to Desmos, the SOC one, to get that. But there's a ton of resources at Collected New York. And
There's actually a lot of discussion on Collected New York. There's a lot of teacher discourse. I tried this in my classroom and it worked well. I tried this in my classroom and it didn't work well. I adapted this lesson for online, and this is how I did it. It's a great website.
And then this is the homepage of the Adult Numeracy Network. There are lots of teaching resources here. Teaching resources and also instructional routines. One of them was Notice Wonder, which we used today. So we got tons of things that are available.
Well, Patricia and Sherry, we're at the top of the hour, and that was a fantastic presentation. A lot of really good back and forth and participation. I just want to thank you both for an excellent webinar today. I want to thank everybody who participated and joined us today. I hope everybody has a great day and a great rest of the week. Thank you very much, everybody.
Yes, thank you. Thank you so much.
Thanks.
Thanks, James.